All right, to summarize, the one way of estimating precision, when you've got two measurements, when you've got two things side by side, two data points, and you're trying to estimate the same thing, or you've got two instruments measuring the same thing, you can use the data quality indicator of relative percent difference, which is the difference between the two, and you've got to always keep track of which one you're going to take first, although it doesn't really matter. Although in this case, you could see that if we did it the other way, we would have had a negative value, which is fine as long as you understand what's going on. So the difference between the two divided by their average, and if you want to turn it into a percent, it's multiplied by 100 for percent. Now we can use this data also to look at bias. So what happened here was a slowly increasing bias and then leveling out so that you see a consistent difference between the two. We had the one probe that was hotter down near the bottom where the heating pad was consistently biased high. So a bias is a consistent difference in one direction. So the same data, and this is what's confusing a lot of times about co-located, for example, PM 2.5 data, is because the same data, when you look at it over time, you can use it to estimate both precision and bias. Because, for one thing, ideally, you would have these lines crossing. That would be showing, and overall, if they both agreed, sometimes they were far apart, but on average, they crossed and were averaged out to be about the same, then you would see that overall you don't have a bias between the two. So sometimes one's a little higher, sometimes one's a little lower. That's not the case here. Here you see a bias. So in this case, you could say, this data really isn't that great for estimating precision, but because I see that there's a bias. So until I recalibrate or change my system to get rid of this bias, I can't use this data to estimate precision. So how would you, in this case, estimate bias? So the equation for estimating bias is really pretty similar to the equation for precision, except that you decide which one is going to be your true value, and instead of dividing by the average of the two, which is the case, which one I always do is divide by what you think the truth is. Now, if you have overall, maybe an average, sometimes one's higher, sometimes one's lower, like you might see, in this case, if they continue to cross, then you would say, okay, what my estimate of the truth is the average of the two, because that's all I've got. However, in this case, we're going to say, you know what, I think in this case, the cooler one, the one that was near the top, near the ice water, is the true value, and I think we have a high bias here. So how would you calculate bias?